Yes, that's right. So again, I am repeating what I have told. So what is timer? That means timer is an electronic device which will generate the timeless signals. A timer based on the basic timing signals, that is a clock signals, there is a counter, binary counter, which will be implemented up or implemented down. That is, there are two modes of the counter, that is the counting mode on up and the countdown. That is down counter or the up counter. So what will happen? That means either that means the, the count registers, content of the count registers will be implemented upon occurrence of the each successive pulse applied to the timer device, and there is also a match registers or presetable register. Presetable registers can be programmed with a count value. When the current content of the timer device matches with the content which are stored in the presetable register, then what will happen? Then a timing signals will be generated. That is the working principle of the programmable time. Every microcontroller has a two types of. Every microcontroller has a few timers, independent timers or programmable timers, which can be programmed, which can be configured as a timer as well as the counter. There are two modes of operation of the timer and the counter. I will describe. So MCS51 microcontroller has a two timer, which are nomenclature as timer 0 and the timer 1. Both are of 16-bit wide, means its count register consists of a 16-bit. But 8052 has three timers, which are nomenclature as timer 0, timer 1 and the timer 2. Anyway, what is the timer signal? According to the pinout diagram, we can find P3.4, that is port 3, fourth line, and the port 3 fifth line, P3.4 and the 3.5 as the signal which are the functional name is T0 and the T1. That means the timer resides inside the chip, or what is called the on-chip programmable timer. So timer accesses the basic clock signal, timing signals. What is the basic clock signal of 8051? Normally 12 megahertz or 11.051 megahertz. Or the basic clock signal, there is a provision that basic clock signals can be divided by a programmable divider. So that I will describe how the clock signals can be programmed for a timer or on-chip timer. So when the terminal count will reach, that means when the match register content will be exactly equal to the count register, then timeout signals or the terminal count signals will be produced over these pins. That is 3.4 and the 3.5. So these are the output signals. And the 3.4 and the 3.5 are multifunctional pins, which can be programmed as a basic input-output, or it can be programmed as a timer out signal. So only there are two signals. But in case of 8052, additional signals from the port 3 are coming out, which has the functional name of T2. So this is the architecture of the timer signal. Now, what is the operation of the timer? Which can be, what are the registers say associated with the timer? So there are data registers. That is data register means which can store the presetable count of 16 bit, which are nomenclature internally as low byte, that is TL0, and the high byte TH0 for zero timer or timer 0. So there is another timer, that is timer 1, and for them the functional name of the low byte timer register is TL1 and the high byte timer register is TH1. And these are the relative bit position of the programmable timer. So what will happen, how it will work? First of all, there is another control register associated with the timer, that is two timers, which is called the T mode registers, T mode, which can set the mode of operations of the timers. And the relative bit has got a physical significance, that is M0, M1, C stroke T gate. So these 4 bits are associated with the timer 0, and the upper 4 bits, upper nibble, is associated with the timer 1. That is the architecture. Now, what is the functionality of these 4 bits? It must be, before going through the timer programming, the significance of the all 4 bits must be learned. So these are the functional description for timer 1. The 2 bits are marked as M0 and the M1. So there will be 4 combinations, as 00, binary 00, and the 1-1. That means the T mode registers can be programmed by instructions, MCS51 instruction. First, the 2 significant bits associated with the timer 1 and the timer 0 means, that means when the content of these 2 bits become all 0, this is called the mode 0 operation. So under mode 0 operation, 13-bit timer mode is possible. 13-bit means all the 16-bit will not be in action. That means because number of counts will depend on the number of bits. For example, 13-bit means 2 to the power 13 number of the counts are possible for clock signal. Again, each timer can be programmed as an 8-bit, lower 8-bit and the upper 8-bit. That will be clear when the timer programming will be described. Anyway, first you have to understand the mode of operation. For mode 1, the 2 bits combination is 0-1. So for mode 1, under mode 1, a 16-bit timer mode operation is possible. That means TH X and TLX means TH0 or TH1, TL0 or TL1. That in combination, both are in combination, which will store the 16-bit binary count during programming the control registers. Not control register, timer data register, because these are the timer data registers. So for mode 2, the combination is 1-0, and in that case, each timer, that is timer 0 and the timer 1, are configured as an independent 2 8-bit auto reload timer. Now, what is the meaning of the auto reload? Now the duration of the time delay for 8-bit definitely will be smaller than that in case of a 16-bit timer mode of operation. Now, what is meant by the auto reload mode? Now, when the terminal count will be reached, that means when the content of the data registers, timer data registers, will match to the count registers, then the timing signals will be coming out from the pins 3.4 and the 3.5 for the 2 timers. But whether the timer will proceed for the next cycles or it will stop permanently. So again, the programmer has to start the timer by presetting the timer register, data registers, and so on. Under auto reload mode, when the terminal count will be reached, then automatically the last presetable value in the timer registers will be reloaded. So there is no need to again assign the timer data register further under the instruction. So that means the user at the beginning of the timer programming only set the timer data registers content in the form of 16-bit or 8-bit. In fact, 16-bit, the auto reload mode is not possible. It is only possible for 8-bit auto reload mode. So upon reaching the terminal count, there is no need to again further assign the 8-bit count value. The last 8-bit count value, which will be temporarily set, will be automatically reloaded to the timer data registers. So that is why the name, the meaning of the name is auto reload timer. This is a very powerful feature. That means auto reload timer. That means when the microcontroller is powered up, this auto reload mode of timer will save the time to assign the timer content or the content of the timer further. So that is the meaning of the auto reload mode. Then for this mode of operation, timer 3, split timer mode. Split timer mode is a very advanced feature. That means the 16-bit timer can be divided into the two parts and which can be simultaneously operated with its own basic clock frequency. Now the question will arise whether the timer clock frequency will be derived under the split timer mode of operation from the same clock source. No. There is a feature that means even though the timers are operated with the split timer mode, that is under mode 3, then for them the basic timing signal, that is the clock rate, may be different. But here the clock rate will be the same. So the split timer mode gives you the operation, gives programmer the facility to operate the two timer of 8-bit mode. And there are two timers, mode timer 0 and timer 1. That means in an effect, 4 independent timers are possible under split timer mode. So each timer mode of operation has got a significance. So this is very important. Now what is the meaning, significance of the C stroke T? Counter stroke timer. I have described the operations of the timer. Now how that means yes, the C stroke, if the C stroke T bits is reset, that is 0, the T mode register selects the operation of the timer counter unit as a timer mode, which I have described. But if the C stroke T is reset to 1, then the timer is operated as a counter mode. There is a difference between the counter mode of operation and the timer operation. So that is why it is called that is why the internal timer is called the programmable counter timer. That is timer stroke counter. Now what is the basic difference between the timer or counter? This is the functional diagram of the timer. Operational diagram, that means the inside this, that means this is AND gate. One input of the NAND gate is coming from the another registers or TR, Tcon register bit. If this bit is 1, set to 1 logically, then and then only the timing signal coming from the basic crystal or divided by timing signal will pass to the output of the AND gate. If this is 1. Otherwise, if this is 0, the timing signal will not be passed. So, if the timing signal is not passed to the time and data registers, TH and the TL, then how the registers, that means, will be decremented or incremented. So that's why it is essentially needed for programming, under programming, the TR bit should be set to 1. Where the TR bit will lie in TCON registers. I will describe what is the functional description of the each bit of the TCON registers. I can show you just now. That is timer control registers, which is called. TCON registers. Yes, it is. Yes. It is a bit format of the TCON register. So there are two registers. One is T mode and another is TCON. T mode register will set the functionality of the different modes under timer, and the TCON registers will set the different functions, that is, of the each timer. What is that? So these 2 bits are reserved for the timer 0, and 2 bits, and that means this bit also called TR0. That is timer control register 0 timer, as well as the IE0, that has got the separate functionality, and the IT0. Similarly, that is 3 bits. But for timer 1, it has IT1, IE1, and TR1, which is the timer control for the timer 1. There are another bits called TF0 and TF1, which are nomenclature as the timer overflow. I will describe. So that means the TCON register, all 8 bits has got a different meaning. And setting or resetting the each bit of TCON register, it is possible to drive the timer in a different manner. The simplest manner is, that means we must set the TR bit for the respective timer. That is, timer TR0 should be 1 or TR1 should be 1. Then this, according to the block diagram, or this block diagram, this is TR. That means this functional diagram will appear for each timer, timer 0 and the timer 1. So when the terminal count will reach for the 16-bit register, what will happen? It will set the timer flag bit in the TCON register. What is the meaning? Initially, for timer operation, timer in progress, the TF bit should be cleared or reset, that is 0. But when the terminal count will reach upon time delay, that means number of passing the successive clock pulse, then what will happen? This bit will reset. That's why you can now understand the significance of the TF bit, that is TF0 and the TF1. For timer 0, the TF bit lies here, and for timer 1, TF bit is right here, TF1. So when this bit will set 1, which indicate, that means the timer has produced a time delay, and the content of this bit will be passed to the port 3.4 and the 3.5. So that means the content of this bit, nothing but a logical signals associated with T0 and T1. That means it will set the timer overflow flag register, 1 bit. Also, that means whether the time delay has occurred or not, so the trace will be stored here in the TCON registers. But these TR0 and the TR1 bits can be set under either instruction, that is write mode. As well as it can be reset to 0 and reset to 1. But under instruction TF0 and the TF1 bit cannot be set because it is not writable. Under hardware operation, when the terminal count will be reached, then and then only the TF0 and the TF1 bit will be set. And it cannot be set by either instruction. But under instruction or program control, this bit can be reset for the further timer operation. Because the status of the TF0 and the TF1 bit set, that is, yes, the timer has gone through one frame because the terminal count is reached. But under auto reload operations, automatically the TF0, because the TF0 and the TF1 will stay for one time period of the clock signal, and it will be automatically cleared by setting the auto reload mode. So that is the advantage. So that means these are available in the instruction, the functionality is available in the diagram. So you have to understand that this bit, this logical diagram, or the timer block diagram. Timer block diagram. This diagram as well as the Diggs diagram. So what is the significance of the TR bit I have described here? And these are called the timer registers. That is, T mode registers is called the timer register. But the timer data registers are THX and the TLX. So again, mode of operation are described and its significance. So timer 0, there are three modes of operation. That is, what is that? What is those? Mode 0, mode 1 and the mode 2 and mode 3, 4 operations. So mode 0 means the 13-bit count. The resolution is 13-bit count mode. Mode 1 means 16-bit count. Mode 2 means auto reload mode 8-bit, not 16-bit. Mode 3 means split timer mode. So what is the timer? Simplest is that means mode 0 means the timer can be operated with a 13-bit mode of operations. So what will be the maximum value on 13-bit in binary? Can you calculate? 13-bit, that means 16-bit means 3 extra bit. So most significant 3 extra bit will not be considered. So what will be the value of the 13-bit? Further 2, then that means you have to divide by 8. Then you will get what is the maximum value of the 13-bit. If you calculate yourself to understand what is the maximum count for 13-bit operation. Now, what is the time delay calculation? How will proceed for the time delay calculation? 8051 oscillator frequency is divided by 12 and then fed to the oscillator according to this diagram. So the 12 megahertz will be divided by 12 and it will be 921 kilohertz. In fact, 11.059 is the general clock frequency. So 921 kilohertz is the basic timing signal for the timer operations. So, trying to increment the timer count by one timer tick, there is one clock signal, can be determined as below. Tick is equal to 1 by f oscillator by 12. F oscillator is 11.059 divided by 12. So, according to the steps, the value of the tick, that is time delay for each clock signal, divided clock signal, will come out as 1.085 microsecond. Try to understand the calculation. Now the timer value for the required delay can be calculated as below. So if the delay, that is the timer count registers, the time delay will be the content of the timer count registers either in the form of 13-bit or 16-bit multiplied by the tick. That means one count will produce the time delay by tick. So register value to produce a given time delay will be calculated according to the timer maximum minus count, and this is the formula. So according to formula, how much binary value in the 16-bit or the 13-bit you have to load, that will depend on the count register. So for a given time delay generation, say 6 microsecond or 1 millisecond, the timer data registers can be calculated. In 805 application, we have learned how the time delay generation can be programmed using software counter. That means using the instruction with a control loop. But here is not required because once the timer is programmed and configured, so only the programmer has to calculate the appropriate time delay for getting the appropriate count value for getting the given time time delay in second. So now what is the advantage? That means the timer can be programmed. Once the timer can be programmed, a time delay signal will be automatically generated without hampering the other tasks of the microcontroller. Otherwise, in the disadvantage of the software counter is like that. That means when the microprocessor like 8085 will execute the instruction within the loop for time delay generation, 8085 cannot do any other tasks. So that's why the timer, that is the advantage of the programmable timer. That means the programmable timer, once it is programmed, it will produce the required time delay. So definitely the programmable timer can be operated under once or under auto reload mode. Periodically, it will generate the timing signals. For example, the timer operated under mode 1, you can calculate for 16-bit because it will, the timer 1 will generate the higher time delay value because the basic count register is 16-bit. We will describe this is a C program. Whenever we study that programming part, then how the peripheral can be programmed, especially timer, it will be clear. So timer in mode 2, that means auto reload mode of 8-bit. So what is the maximum time value for the 8-bit timer register, data register? Only FF, that is 256. So it is much lesser. The timer value for the required delay needs to be loaded into timer count register, that is TH, and but the count register has got a two parts. One is the least significant byte, another is the most significant byte. So TL. But under auto reload mode, automatically once the auto reload mode is set by the programming the T mode register, the value of the TH and the TL will be the same automatically. So there is no scope to set the 16-bit value. You have to understand. After loading the values to the register, the timer must be started. How the timer can be started? By setting the TR bit in the TCON registers. So once initially during the programming, the TR bit should be 0. Otherwise, what will happen? Clock signal will be passed. But upon completion of the configuration of timer, the last step is to set the TR bit. That is timer run. The significance of the TR is called the time and run control bit. So once the timer run control bit is set, then the timer will start its operation. This is clear from this diagram. Did you understand the complexity of the timer programming by microcontroller or by programming? So this diagram is depicting, that means how the run control bit coming from the T-con register should be set separately to proceed for the timer operation. And this is the delay. How the timer, that means calculation for the 250 microsecond delay could be done. That's the same procedure, same step. There is mode 2. But what is mode 3? Now, again, in T mode register, there is another signal called the gate. What is the significance of the gate signal? Gate. Generally, the gating control when is set, that means when the gate signal is set by a logical signal 1, then what will happen? And the timer counter is enabled only while the interrupt 0 or the interrupt 1, that is separate things, pins is high. So that means the operation of the timer is connected to the interrupt control. That is another peripheral. So right now, gate should be 0. Or gate can be 1, no problem. So gate should be 1. This is described in the timer operations. The gate normally should be 0, and the timer can be start by setting the TR control bit and stop upon terminal count, or alternatively, if the TR control bit is set to 0, then the timer will stop. If the gate is 1, then what will happen? Then the harder way of starting and stopping the timer by an external source is achieved. That means the gate 0 means internally the timer operation can be controlled by the TR bit, and that is required the instruction. So that is all the internal way of controlling the timer operation. But when the gate is 1, then what will happen? Applying the external signal, maybe a low frequency square wave or the digital signal, the internal timer operation can be stopped or started. So that means the timer operation can be internally started or stopped with the help of TR control bit, or it can be started or stopped by the gate control bit. For timer operation, the C stroke T bit should be 0. Now, what is the counter operation? And to generate the time delay, these are the steps which I have described just now. When we learn the instruction 8051, then the body programming segment will be clear. Now, what is counter? So programming the timer as a counter, what does it mean? That means when the C stroke bit is set to 1 in the T mode register, then what will happen? It decides the source of the clock for the timer. That is when C by stroke is equal to 1, the timer is used as a counter and gets its pulse from the outside of the 51. That means in case of a timer operation, the timer on-chip timer accepts the timing control signal by the divider, by frequency divided signal. But when the C stroke T is set to a logic 1, then the internal oscillator circuit will be blocked. And the timer is waiting for accepting the timing signal from the external timing signal. How? From pin 14 and the 15. So from the pin 14 and the 15, these pins are called the T0 input and T1 input. Sorry. Extremely sorry. That means I have told that T0 and the T1 are up on the terminal count, but it is not like that. It is an input to the MCS 51. That means the T0 is associated with the timer 0 input. That may be a timing signal, that may be high or low, or maybe a square wave, and the T1 is for the same. So the timing signals will be accepted by the signals over occurring at the pin T0 and the T1. And the C by C stroke 1 will be 1. That means the timer will be preceded by the counter. So upon occurrence of the each signal, there will be a measure of the event count, which are stored in the timer data register. So if we set the timer data register initially 0, then running the timer as a counter, what will happen? We get a direct occurrence of the number of pulses, or measure of the occurrence of the number of pulses, which is called the event counting. For example, and after a certain time, we can block this operation by setting the C by T is equal to 0 and the TR is equal to 0. But the timer data registers can be read back under instruction. So how much amount of the pulse has been proceeded or has occurred, it is possible to measure that. So the counter mode of operation is required for real-time applications. Which type of real-time application can you guess? That is event counting. That means there are some event in the form of pulse, digital pulse. So how many pulses have passed or have been produced by the external resources that can be measured in terms of the count. So there are suitable applications, that is intraday applications, automatic intraday applications, which can produce the number of occurrence of the number of pulse, digital pulse, positive going pulse. It can be counted with the help of the counter mode of operations. Otherwise, generally the timer mode of operation. So this is the diagram of the counter mode. When the C by oblique stroke T is set to 1, so from that timing signals is coming from the external pin, that is T0 at the T1 under mode 1. This is for mode 2 operation. So counting programming. And these are the functional diagram, which is very important, not the circuit diagram, so that how the external signals gate can enable or disable the timer operation. So there are assembly language programming for the timer and also C programming for the timer. We have not started yet the programming part or instruction part. So from next class, we will immediately start the instruction. Otherwise, for peripheral theory of working theory of the peripheral is are simultaneously read with the help of the program. But for arithmetic program, the concept is not required. So if you have the if you can write the flowchart or the algorithm, then you can immediately implement in any type of a microcontroller like MCS51 or microprocessor. So for mathematical or arithmetic programs, it is not required. But for peripheral programming, the hardware concept is very much required. So try to understand the timer operation. We have, to some extent, studied the IO, the functional description of the IOs. So there are 4 IOs, okay, which are designated as P0 to P3. Each IO is separate or the different types of the internal architecture, which I have discussed in last class. Similarly, you must go through the timer, the functional diagram of each timer mode of operation. Otherwise, you cannot understand, you cannot program the timer for a given application. I have sent the class notes on IO as well as the timer programming already to your group mates. So please go through. Thank you for today's class.